Hello everybody. This is not really from the textbook. Like it says, this is a supplement. This is in section 1.4 we talked about just some angles and some different types of angles and that kind of stuff. We measure angles normally with degrees, just a measure of angle, how big of an angle is or how small an angle is. And so with this part that we're going to do here, there is a different type of measurement for angles. It's called a radian. And so it just kind of fits with this section. Normally this is not taught till really Algebra 2 Trig. You start to see it a little bit, so that's your class next year. Sometimes you'll start to see it in calculus or pre-calc, that kind of thing. But you guys are sharp, you're ready to handle this thing. And it's not difficult, but it's a different type of measurement for angles. That's the biggest thing. And how you know it's in radians, as it says in the first line, usually in terms of pi. Doesn't have to be, but it usually is. So, I guess a way to recognize this stuff, or a way to think about this, the metric system. When we're dealing with measurements of length, okay, kilometers, meters, centimeters, and then what we're used to, miles, yards, feet, okay, they all do the same thing. They measure a distance. They're different numbers for the same distance, but they're still doing the same thing. And that's kind of the analogy between a degree and a radian. They're measuring an angle, but they're just using different numbers to measure the same angle. All right, here is your definition for a radian. It's defined as the angle that is required to intercept an arc the same length as the radius. Okay, what that means is, if we start here on the positive x-axis, go to the origin, come out here. Here is this angle. On the interior of that angle is this arc. Okay? It has a certain length. It's not a straight line or anything like that, but it has a length. The definition of 1 radian, it is when the length of this arc here is the same as the radius of the circle. That's what 1 radian is. So no matter how big the circle is, how small the circle is, the angle that intercepts an arc that has a length the same as the length of the radius, that is 1 radian. Okay, now that's just what it's defined as. You don't really need to know that, but that's just where it's coming from. So when you compare degrees to radians, this thing right here is called a unit circle. And, don't worry about this too much. There's just some terminology that kind of goes along with this stuff. So, a unit circle basically means it's a circle, it's centered at the origin, and it's got a radius of 1. When we're measuring angles with this thing, we always start here on the circle, on the positive x-axis. That is your 0 degree mark. Angles go up, going counterclockwise. So this is a 90 degree angle here, there's your 90 degrees. You keep on going around, 180, 270. You go back around full circle, that's 360 degrees. With radians, you do the same thing. It starts here on the positive x-axis on the circle. That is the 0 radian mark. You go around, you're at pi over 2 radians. Halfway around the circle, pi radians. 3 pi over 2, back around is a full 2 pi radians. Now, where this comes from, if you think about the definition of a radian, it has to do with an arc length. If you go all the way around the circle, that distance is the circumference, which is 2 pi times the radius. This is a unit circle. It has a radius of 1. 2 pi times 1 is just 2 pi. So as far as a radian is concerned, you go all the way around the circle, you went 2 pi radians. All right? So now, looking at this, looking at these two circles, we can easily compare radians to degrees. Pi over 2 radians is on the positive y-axis. 90 degrees, positive y-axis. So 90 degrees is the same thing as pi over 2 radians. And they did write the word rad here, short for radians. You don't need to. When it's in terms of pi, it is just implied. It's a radian. All right? Over here on the negative x-axis, pi is the same thing as 180 degrees. On the negative y-axis, 3 pi over 2 is the same thing as 270 degrees. And all the way around the circle, back to the positive x-axis, 2 pi is the same thing as 360 degrees. Now, there are some connections with all of these. If you take this 2 pi equals 360, divide by 2, the 2's cancel out. You just get pi equals 360 divided by 2, you're back to 180. All right? This is the key thing. We're going to be converting between radians and degrees. There's a couple ways you can do it, but this one is really what you want. All right, so to convert between radians and degrees, it doesn't matter which direction, starting at degrees, going to radians, or going the other way. The paper that you're going to get in class, it'll show you what you can multiply by to do this, but it's two different things, depending on if you go from degrees to radians or the other way around. I don't like to have a bunch of stuff that I got to memorize for this thing or that thing. Here you go. Here's one thing that will allow you to convert between radians and degrees. This ratio. Pi and 180 degrees are the same thing. If you know a radian, you plug it in. This becomes your variable if you're looking for the degrees. Same thing works the other way. Pi over 180 is the same thing as, if you know the number of degrees, plug it in. The radians is the unknown, so you'd solve for x there. Now, there is, if you have a radian in terms of pi, like it says right here, there is a simpler way. Just take that pi out, replace it with 180. All right? So, a couple of examples here. 2 pi over 5. I want to convert this to a degree because it's a radian. I want to convert it to a degree. And so like it says in this part right here, take pi out. Pi is 180 degrees. So we're going to take out the pi and replace it with 180. They are equal amounts, so it's just a substitution divided by 5. Okay? So turn the calculator on. 2 times 180 is 360. Divide by 5. 72 degrees. 2 pi over 5 is the same thing as 72 degrees. All right? That's how that can work. Fairly simple. For 60 degrees, to convert that to radians, I'm going to go back up to here. So, we use this equal proportions. Pi over 180 is equal to, we don't know the number of radians, but we do know 60 degrees. Okay, these are just setting up equal proportions. So we want to know the number of radians. We're going to solve for x. Multiply both sides by 60. So what you get is x equals 60 pi over 180. There are some common factors here, so we're going to simplify that. 60 is the common factor. So that's going to go to pi over 3. 60 degrees is the same thing as pi over 3 radians. Okay, just a real quick introduction to what a radian is. We'll work on it a little bit in class. Kind of mentioned it, the sheet that you'll get. It's got a big description of this, kind of similar to what I've talked about here. And then you'll work on some of these problems, converting them. Bye.